In this episode, we're going to set up an end-to-end automated container deployment pipeline. We'll walk through going from a Git push to a change deployed into production with zero downtime in just under a minute. This is commonly referred to as continuous integration and continuous delivery, or just CI/CD for short. Before we dive in, I want to mention that I'm approaching this episode as if you're totally new to the concept of CI/CD and automated container deployments. So if you're already a CI/CD expert, this is likely nothing new to you. My intention here is to show off some cool stuff and lay down some foundational knowledge that we can build on later. Back in episode 55, we chatted about main areas of functionality that you'll likely run into while running a larger scale production container deployment. Then in episode 56, we chatted about container orchestration basics and deployed a Kubernetes cluster. Well, in this episode, I was thinking it makes sense to walk through what a very simple deployment pipeline looks like. Let's jump over to the containers in production map for a second. So in episode 56, we chatted about how orchestration is sort of the heart and soul of your container infrastructure. In this episode, I wanted to look at things like version control, continuous integration, Docker registries, and continuous deployment. The idea here is that we can automatically feed code changes into our container orchestration layer without doing much work. Let's zoom out for a minute. So we already chatted about this orchestration area. Now we can go over what a pattern looks like for deploying changes automatically in this area. This is an architecture diagram of what we're going to be building today. So down here we have our developers. They're going to be pushing changes into version control, and that's going to trigger a build step. That build step will look at our code, pull down any dependencies, compile it, and build a Docker container. From there, we're going to trigger a zero downtime rolling deployment across our Kubernetes cluster. This is also a demo application that will be served up to end users on the internet. You can actually check it out too. If you browse over to sysadmindemo.com, you can see the website we'll be updating. This was the demo website used in episode 56 for testing container load balancing in Kubernetes. The idea was that this website shows you the hostname of the container that served your request, and as you refresh the page, the hostname changes. This sort of proves out the idea that load balancing is working and that there's multiple container instances running behind the scenes to support this website. There are some things that I don't like about this website though. For example, I don't like how the hostname wraps across multiple lines as you reload it. And I also think we should swap the hostname and the title around so that the title's actually up top and the hostname's below. These are a few of the changes we'll make and then automatically deploy them in just a few minutes. So why do this at all? Well, let's jump to the architecture diagram for a minute. So we have our developers here, and they're typically using stuff like a text editor, command line tools, and Git. They have some awesome new features that are ready to release, and they want to get this live as soon as possible. Sure, they could go ahead and manually deploy each and every change, but this greatly increases their manual work, likely introduces human error, and as the team grows, each person will typically do things just a little bit differently, so there's likely that steps will be skipped. So it's kind of nice to hide all of the complexity and automate things by way of continuous integration and continuous delivery pipelines. This not only makes developers' lives easier, but it also increases the velocity at which your company can deploy changes out into production. And this greatly reduces the risk of each deploy causing havoc as they're much smaller and way easier to debug. From my perspective, much of this tooling is sort of a necessary evil, in that you just want to push changes out to end users as soon as possible. You don't really care what's happening behind the scenes as long as it just works. Using something like this architecture gets you from Git push to a live change in production in around a minute. I should mention that in the demo today, there's no guardrails. This is a total bare bones deployment pipeline. We're not doing any testing or canary releases here or anything like that. I just wanted to show you the very minimum needed. Then we can build it up and explore how to make this much more robust. Basically, we're aiming for fast first, and then we can make it safe later. So now that you have an idea of the high-level plan and motivation here, let's check out what's happening under the hood that makes this all possible. For the example today, we're going to be using Google Cloud. But honestly, these boxes are pretty swappable, and on pretty much every platform, you'll be looking for similar functionality. So let's just blank out these boxes here and walk through the architecture step by step. First, we're going to need a version control system. For the majority of people, this is going to be something like GitHub, Bitbucket, or maybe a hosted internal version of GitHub Enterprise or something like that. Basically, we just need a place to stash our source code. Second, we're going to need something to coordinate our continuous integration pipeline, or just CI system for short. This is pretty commonly Jenkins, maybe Circle CI, Travis CI, or something like that. So we'll configure our version control system in a way that triggers a notification over to our CI system that there's some work to be done since we submitted some new code. This trigger or notification is often in the form of a webhook or something like that. After a notification from our version control system, your CI system will typically pull down your source code, test it, compile it, and build your packages. This is also where the Docker build typically happens. Next, your CI system will typically build and push your application wrapped in a container into the Docker registry. Most cloud providers have their own registries. This includes AWS, Google Cloud, Azure, etc. Tons of people are also using Docker Hub too, or some private registry instance they've installed. A good example of a private registry would be using something like Red Hat's OpenShift. From here, your CI system will likely trigger some type of deploy event. This is often called continuous delivery or continuous deployment, or just CD for short. For me, the lines between continuous integration and continuous delivery are pretty blurred. Oftentimes, you'll see one tool doing both jobs here, and oftentimes that tool is Jenkins. The reason I'm chatting about this is that lots of companies will market that they have some sort of continuous delivery offering. So I just want to mention this as you'll likely run into it. But the core idea here is that we need some way to trigger the orchestration tool to let it know that, hey, there's some changes that it needs to deploy. For me, this is why orchestration is so important, in that you can let it manage the rolling deployment and generally just take care of it. Without orchestration, you, the sysadmin or DevOps person here, will likely have tons of manual work to keep things running and afloat. If you haven't seen it already, I highly recommend watching episode 56 as I chat about this quite a bit. Finally, we need a way to route user traffic into the cluster so that it hits our newly deployed application. Again, this is where orchestration plays a pretty big role in that it'll coordinate routing traffic to the correct instances running our latest code. If you think of things in this abstract way, it doesn't really matter the platform or orchestration tools you're using, in that you're just looking for this functionality. Personally, I'd aim to create this workflow by seeking the tools available to me on whatever platform your company's using. Sure, I'm using Google Cloud for the demo today, but if you look at things from the perspective of functionality needed, you could easily map this to AWS too, or something else. This works really well if you need to, say, translate from one platform to another. Or maybe you got a new job at a new company and they're doing things a little differently. You can easily adapt if you look at things from this perspective. In this AWS example here, we're using GitHub for version control, Jenkins for continuous integration, and then we're using AWS's container registry and then AWS's Kubernetes offering. And all this is sitting behind AWS ELB. I find that a lot of these tools are extremely swappable, but the workflow and the end result is pretty much the same. All right, this is likely enough theory. Let's actually make this happen by way of a demo. So I've created an example project in Google Cloud, and we're going to build out the architecture piece by piece. By the way, this is the console for Google Cloud if you've never seen it before. First thing we need to do is configure a Git repository where we can stash our website source code used for the demo. If we go up to the hamburger menu icon up on the top left here and expand that, we'll select Source Repositories. I'm just using the UI here, but you could easily use the command line, or better yet, use something like Terraform to do this. From here, we're going to say we want to add a new repository. Then I'm going to choose the option to create a new repository. You can also mirror an external repository, say something like GitHub, so that you could still use this workflow even though your source code's sitting outside of Google Cloud. Next, I'm going to call this new repo demo. It just takes a second to create this new repository. Next, I'm going to choose push code from a local repo because I'm pushing code directly from my laptop into this repo. Then I'm going to choose the manually generate my credentials option. Now we can just use these two git commands like a normal remote repo, and it just works. I chose this option because it fits pretty well with my existing workflow and I'm heavily used to it. Let's flip over to the command line and connect things up to this new Git repo. In the local directory here, I have the website's index.html file, the main.go web server, a Docker file, and this cloudbuild.yaml file. So let's initialize the local directory as a Git repository by running git init. Then if I check the status by running git status, you can see that our files haven't been committed or pushed yet. So let's add them by running git add dot. Then let's commit the changes by running git commit -m init commit. So if we flip back to the Cloud Console, let's copy this command to connect our local repo up to this remote one hosted in Google Cloud. Then if we switch back to the command line, let's paste it. All right, so we have things wired up now. Our local repo on the laptop can push changes up to the Git repo hosted in Google Cloud. But I don't want to push any changes yet. I could, but I want to wait. Because I want to wait to configure that trigger for building things when new code is pushed into that repo. If I just pushed it now, nothing would happen. So let's check out that architecture diagram again. We just completed step 1 for setting up a version control system. Now we need to configure the CI/CD step where we trigger events based off of new source code being pushed into that Git repository. To make this happen, let's head back to the Cloud Console. We're going to go back up to that hamburger menu icon in the top left, and we're going to go down to Cloud Build. Let's select Triggers. This is how we're going to trigger events off of new source code being pushed into that repo. This basically says what I've already chatted about in terms of triggering events off new source code changes. So let's go ahead and create a trigger. We're going to select Cloud Source Repository as the source event for this trigger. Now I'm going to select that demo repository that we created earlier. Then we're asked how we want to configure the settings for firing off this trigger on events that happen in our demo Git repository. For me, I'm going to leave most of these as the defaults, but you could have a specific event trigger based off a tag or, say, a specific Git branch. The one thing I am going to change here is this build configure step, where you can choose how you want to define the actions that will be taken when this event actually triggers. I'm going to choose the cloud build.yaml file option here. We'll actually walk through what this looks like in a second, but the gist is that this file outlines a series of steps that needs to be taken when this event actually fires. All right, so the settings actually look good now. Let's save this trigger. Great, so now we have our build trigger configured so that when new code gets pushed into this demo repository, we'll be looking for this cloud build.yaml file, which outlines the steps on what it needs to do. So let's jump over to a text editor and actually look at what the steps are. Here's our website source code. I'll post this up on GitHub and I'll throw the link in the episode notes below so that you can have a look if you want to too. So let's have a look through the cloud build.yaml file. This file basically allows you to define steps or actions that need to be taken when that event is triggered. There's a bunch of supported build types that you can use, but I'm using Go, Docker, and the Kubernetes ones here. So let's go through this step by step. After the code has been pulled down by the event trigger, first it's going to run this go get step. This will pull down all the dependencies required to compile this application. Next, we're asking to have this application actually compiled. Once we have the application compiled, we're going to go ahead and run a Docker build based off the Docker file sitting in this repository. Next, we're going to deploy this newly built application out to our production Kubernetes cluster. Finally, this is what our image is going to be called, demo, and then tagged with the Git hash. This entire deployment is actually really simple. So the event trigger is going to fire. It's going to look for this cloud build YAML file. Then we're going to follow these steps, which is actually pretty straightforward. So if we flip back to that architecture diagram for a minute, this cloud build.yaml file basically walks us through how the deployment should happen. We sync over the website code, pull down all the dependencies, compile the application, build our container, and then push that container to the registry. The next thing that needs to happen is we need to deploy this application into production via step 4 here by telling Kubernetes that we want to update a currently running deployment with a new image that we just built. Let's flip back to the code for a second. So the problem with this deployment step here is that we're asking the CI/CD system to deploy something to Kubernetes. But how do we handle permissions here? You'll likely run into similar problems no matter the platform that you're running on, so I sort of wanted to walk through this. For example, say that you're using Jenkins on AWS. You need some way to authorize Jenkins to deploy applications into your container platform. The way we handle this on Google Cloud is through something called service accounts, so let's set that up. So let's head back to the Cloud Console again, and I'm just going to find IAM, or Identity and Access Management. Basically, we need to give access or authorize this Cloud Builder tool to deploy workloads into Kubernetes. So I'm going to update this Cloud Build account here. We can do this by clicking Edit over here. Again, this is super specific to Google Cloud, but you'll likely run into a similar situation no matter where you do this. Just the details will be a little different. So I'm going to add another role to this service account and allow access to the Kubernetes cluster. Just going to scroll down here and find Kubernetes and then add Kubernetes the admin option. This could be a little bit finer grained control, but that's what I'm picking. Then we'll click Save. Perfect. Now this Cloud Build tool actually has access to deploy workloads into the Kubernetes cluster. Let's just jump back to the editor for a minute. So we now know what all these steps do. This last step is the one where we just added permission to deploy. Without that permission added, our deployment step would fail with an error saying it doesn't have permission to deploy workloads into Kubernetes. One thing that's totally absent from this file is any testing. As I mentioned before, we're just going for the bare minimum steps needed to begin with. But you'll likely see lots of unit tests, some integration tests, and maybe a canary deploy happening in this file too, to make it more well-rounded. I just wanted to prove out the idea first, and then we can refine it down the road. Cool. So I think we're ready to push our code as everything's been configured. I should mention, I already have a Kubernetes cluster running behind the scenes here. We configured one back in episode 56. The cluster is still configured and routing traffic from sysadmindemo.com to our container instances running that demo website. So we'll be using that existing cluster for the demo setup today. Let's head back to the Cloud Console. You'll remember when we initially created that Git repo, we were given a couple commands. Let's just copy this push command here and head back to the command line and run it. So this is taking our website formatting tweaks that we added earlier and pushing them up to the demo repo hosted in Google Cloud. This should have also fired off our build trigger, so let's jump back to the Cloud Console and see if we can track things down. If we refresh the page for this Git repo here, we should now see our website source code. Perfect, so the Git push worked. Let's just verify the sysadmindemo.com website is still running the older version by reloading this a few times. Great, so now let's check the progress of our build trigger step. I just want to verify that we actually kicked off that trigger when we pushed the code into the Git repo. So if we go over to Cloud Builder, there's this History tab. Perfect, you can see something's happening here, and our event was triggered when we pushed code into that repo. So let's click on this and have a look. This page will give you a bunch of details about the build event. As you can see, it's still in progress, and our build steps were pulled from that cloudbuild.yaml file and populated here. Great, it looks like it just finished. And you can see it took 32 seconds. Here we get a breakdown of each of the build steps and the amount of time that it took. Obviously, this is very minimalistic, and you would likely see much larger build times if you were actually doing testing in here too. But I'm just using a really stripped down process to show you the workflow. Then if we scroll down here, we have the complete build log for each of our steps, which can actually come in extremely handy when things break and you need to debug something. And that's basically it for here. I should probably show you the Docker registry too. So if we go back to the hamburger menu icon and select Container Registry, that will hopefully show us our newly built Docker image. Great, so you can see our newly built Docker image here, and if we click on it, we'll get some details about it. You can see the image metadata here, and the size is roughly 7 megs. This smaller image actually contributes to the pipeline going pretty fast too. For example, if you needed to install a bunch of dependencies or do some software upgrades, you could easily spend many minutes in here. All right, let's verify the change was actually pushed out to our production website. Let's change over to our sysadmindemo.com tab. So I want to change the formatting bit here and swap around the title and hostname. So let's reload the page and see if it happened. Great, it worked. If I reload the page a few times, you can also see that we're running multiple container instances in the background, as the hostname of each instance that served the request is shown here. So it all worked. We now have the title up here and the host names are shown down here. So I know that's a long episode just to show you something that takes less than a minute to actually do. But I wanted to walk you through it like that so that you can apply it pretty much anywhere. The goal here is to understand the workflow behind what's enabling developers to push changes live in less than a minute with zero downtime. Behind the scenes, it actually looks something like this, but you can totally abstract it away to look something like that, so that we can hopefully apply it to wherever you're running your workloads. Before we end things, I just wanted to flip back to the Cloud Console for a minute and show you the event logs in the Kubernetes cluster. So you can see we have a 5-node cluster here. Then let's select the Workloads option from the menu over here. Then click into the demo application that's actually running our example website. This page will basically give you all types of data about the application and how it's currently running. There's also this Events tab here. And if we click into that, you can see a bunch of scaling events. What's actually happening is this demonstrates that our old application was scaled down while our new application was scaled up. This worked for a zero downtime rolling software deployment. Let's change back to our text editor for a minute. I wanted to update the website footer and add a comment about how the site was deployed using a very simple deployment pipeline with a link back to this episode. So we're just going to uncomment this and save the file. Then let's change over to the command line and push this change out. I like running git status just to verify what I think is happening is actually happening. Next, let's run git add, and then let's git commit the change. Finally, let's push this change out. Perfect, so we've now deployed again, and this should have kicked off our pipeline. And then if we switch back to our browser, you can see that the current version of the web page doesn't have that footer we just added. We can even refresh a few times, but it takes 30 to 40 seconds to fully deploy. Okay, so maybe while we're waiting, I'll quickly recommend checking out this Datadog report on Docker adoption. They ran a large sample across 10,000 of their customers and hundreds of millions of containers under their control. In the report, they mention a few facts that are pretty interesting, particularly around orchestration adoption and the lifespan of containers that are running under orchestration. It's really fascinating, and I highly recommend checking it out, particularly facts number 4 and number 8 are the ones I'm talking about. It's well worth the read. All right, so let's refresh the page again. I'm not sure if you caught that, but the footer actually updated as we refreshed and switched back. That's because we're doing a rolling zero downtime deployment in the background here, and there's actually 2 versions of the application running as it's rolling out. So there you have it, a workflow from going from git push to a fully deployed site in around a minute. One final thing before we complete this episode, I just wanted to show you a few illustrations of what's happening when we're running 2 versions of the application at the same time and what a rolling deployment actually looks like. I grabbed the logs and created a table of events. From the start of our deployment all the way to its fully deployed, that took 39 seconds, which is pretty cool. More interesting, though, are the graphs of the rolling deployment. Here you can see the older version of the application where it was phased out. You can see we went from 4 instances all the way down to 0. Sort of this step function across time as we scaled down. Then here are the events for the new application, as we went from 0 instances up to 4. And it was scaled up as a step function too. These graphs actually overlap as they're happening at the same time. So for this time period, both versions of the application were actually running here. One was going up and the other was going down. We do the rolling deploy to ensure that there's always instances available to serve user requests. All right, so that's it for this episode. I'll see you next week. Bye.